Hi, good morning, and welcome to the ZP webinar. Today, this is one of our technical webinars, and it's really discussing some of the questions that have come in just near the end of last week. So let me just dive into it. Today is approximately 8 a.m. London time. Sometimes we have to go a little early because there's a lot of webinars or there's a lot of meetings. But today is Sunday, so there's a lot of things going on. So let me go forward anyway quickly and stop. So we got the ZP Academy. Don't forget you can sign up for free courses on the ZP Academy. Don't forget there's the webinars. This is a good example that we do webinars. This webinar, as you could probably tell, is going out live. We do have collaborations. These generally take place with the UK universities. In Norway, we've got 5. And we also do European ones as well. I can think that we're on a European project at the moment as well. We do make job offers, and we also have our ZP Developer Zone, and we also have workshops. Our workshops are one of the best ways. We do put a lot of free educational material out there. This is a good reflection on that. Today will be quite technical, but we also have in-person workshops as well. So there's in-person workshops. If a link is popping up, by the way, that link, you will be able to find it underneath the video at the end. Sorry, I should say in the description box at the end. So we do have workshops in Norway, Coventry, Norway. That's in November and December. So if you want to meet ZP for real, or you really want to do one of our courses where we cover voltammetry, amperometry, impedance spectroscopy, potentiometry, we talk about biosensors, we talk about total sensing systems, then that is the course for you, or the workshop for you. And it's also live as well. What I mean live, it has practicals involved with it as well, so everyone gets to sort of make sensors and test sensors, and all those methods are actually used. We do have these webinars as well. Today, especially question number 2, which is really about detecting analytes or characterizing a particular material, but it is detecting analytes in a dairy product. Then some of these webinars would be super interesting. And I'll put a link underneath the video so you can find them again. Especially the ones on Sense All. Well, in fact, Julie, because I'll talk about, even though we're talking about screen printed electrodes today, ZP is unusual that we have an entire technology stack that goes screen printed electrodes, hardware. This is the Sense It All. Sense It All sends the data to Julie, and Julie has an API, an application program interface, so that actually you can get the data off our cloud and into your cloud. So Julie's important, the Sense It All webinar is important, and the Food Sense webinar is important because it shows a food and beverage application of this technology platform as well. And we actually use the technologies that I'll talk about today. Even though I'm talking about screen printed electrodes, we use lots of these technologies for measuring in the food industry. We use it for measuring the hotness of chilies and the pungency of ginger, and also the total antioxidative state of food and beverage, which is an indication of shelf life. Let me go forward a little bit more and just say we're going to have a particularly focused conference in I have to change this slide. It might not be on the 19th or 20th of June, but it's June 2024. And we have a particularly focused conference on commercialization of electrochemical assays, which is probably relevant to the 2 questioners today, in fact. So I'll put a link underneath this video. Just to say, what ZP does is when we get technical inquiries, we do give sort of free advice, but we also can do private consulting. Private consulting, private development, and also manufacturing as well. So we're a consultancy. We also contract developer and contract manufacturer of electrochemical biosensors and electrochemical assays. Again, I'll put a link so you can find us. Just to talk about screen printed electrodes, the screen printed electrodes that are producing the highest volume by us are the 501 carbon, the 501 platinum, the carbon hypervalue or the hypervalue carbon electrodes, the hypervalue platinum, and the hypervalue gold electrode. I think today for both inquirers, I got a super suspicion it's going to be the 501 carbon or the hypervalue carbon electrodes that you'll need to use. I'll put these links underneath the video as we go. And I just I clicked the link and it jumped to it. Anyway, let me go on a little bit faster. So those links I'll put underneath the video shortly. If you haven't got potentiostats, then we do have an EIS potentiostat, an impedance spectrometry potentiostat. It'll also do the voltammetry, like square wave differential pulse, obviously amperometry, which is straightforward, and potentiometry as well. So sometimes people, especially when people are developing the electronics, it's good to have a reference machine that you can genuinely believe in. Otherwise, people have kind of sensors and electronics as two variables that they're developing and nothing to compare against. So this is a good potentiostat. We do obviously have the screen printed electrodes. This is the cable that comes with that particular potentiostat. It finishes in what we call 2mm banana plugs. And then there's a connector that will take those 2mm banana plugs and connect into our screen printer electrodes. That's really for doing benchtop work. Question number 1. So this is one of the questions. So somebody is interested in our screen printer electrodes. They know that we do a chloride resilient layer. Now that chloride resilient layer, why do we do it? Because in some applications, sort of things like urine, the chloride, or I should say sample types, the chloride can be either not there or it is variable. So fresh water, for example, has a very low chloride concentration. So you could almost describe it as not being there. Whereas seawater actually does have a chloride concentration, and that chloride concentration is generally quite consistent. So the reason I sort of bring this up is because you can model the referencing potential of a chloride electrode versus chloride concentration, and the referencing potential becomes less sensitive the higher the chloride concentration. I think seawater is about 1 molar, but that's just off the top of my head at the moment. So we have a chloride resilient layer for applications where chloride is either very variable or is in low concentrations and we need to kind of fix it. So what it is, it's a polymer layer that has chloride embedded in it, and it's meant to give above the reference electrodes a sort of fixed chloride concentration. Now it's not perfect, but actually when I think about it, if you've got a particular matrix that you're going to be in most of the time, we can probably tune to that matrix, because essentially if we have something that's quite standard, let's say, and it's designed for our applications, but we could always tune it up. But my kind of take on this is, if you're in an application where the chloride is quite high concentration, and it doesn't shift around that much, I wouldn't try to use the chloride resilient layer. It adds a bit of complexity. But if you are in a sample type where there is no chloride, then I can understand that you may need to use chloride. Now at ZP, you can sometimes fix problems either by playing in the materials domain or playing in the, I would say, the data domain. I prefer to play in the data domain. So even though we have a chloride resilient electrode, nowadays, I've been doing electrochemistry and electrochemical biosynthesis for 23 years. ZP's been around for 9 years. So after all of that, I would almost say that, I prefer to keep things quite simple until I really need to bring in things like the chloride resilient layer. And I'm always convinced that you always need to bring it in. That said, we do have it. We can make it available on our screen printed electrodes, and it's intended to fix the chloride concentration above electrodes. It works best for discrete measurements because after continuous application, the chloride will eventually leach out. They found a desalination cell on our website. I'm sorry to be disappointing on that. We have discontinued that desalination cell, so my apologies on that. They're also interested in our hypervalue copper screen printed electrodes. When you say they're not in stock, I mean, we say on our website that products will ship in 3 to 4 weeks. So that means, if you order something, that it'll ship in 3 to 4 weeks. They were also interested in a particular carbon electrode with a silver chloride reference, but it's only available in 3,000 pieces. But I'll show you an alternative which you can buy, which I think is basically better. Question number 2. So this is a different person, different questions. They're developing a voltammetric assay for dairy products. They need an SPE, screen printed electrodes. They're interested in disposable one-time use. They've got an interesting combination of nickel, copper, and carbon. We do have nickel and copper electrodes, and obviously carbon electrodes as well. I would sort of tend to try and keep away from nickel and copper, just because it's an unusual material and it's not produced by us necessarily in high volume. The electrodes that we produce in high volume are the ones that a slide will come up where I show 5 electrodes. Those are the guys that we're producing in high volume. Our initial requirement is for thousands, and it's interesting actually because one print run by something like ZP could end up producing something like 30,000 sensors. So you should be really careful that people think that high volume is some thousands of electrodes. It's not. It's really, I would even describe it as pre-pilot scale. Anyway, I'll cover that in a bit. I am going to suggest some alternatives to these people today, but I'll have a rationale for why I'm going to suggest some alternatives. Question number 1. Now, question 1A was about the chloride resilient electrodes. So the chloride resilient electrodes have a reservoir of chloride above them, and it's designed to give you a more stable reference in some applications. I would honestly go without chloride resilient until I thought I really needed it. Question number 1B of yours was about that desalination cell. Unfortunately, we have discontinued it, but now I'll deal with questions 1C and 1D. So we do have the copper hypervalue electrodes. Here's a link to it here, which is relevant to question 2 as well, because they were asking about copper as well. So you can see that we can actually deal with copper. I'm not super keen on it because if you want a reproducible product, then it's those products that are produced in the highest volume that are most reproducible. And reproducible is also another, I would also say it's part of quality as well. But we do have our copper electrodes, and under that link, by the way, there was also nickel as well. So you can find copper and nickel underneath this link, and I'll put that link underneath the description of the video on YouTube. They're also interested in this electrode. They were a bit disappointed. I can understand why, that we sell them in packs of 3,000, which means then that we can get to the reason we do this is then we can get to a reasonable price in terms of like €2.17 each. But if you look at this electrode, we have a really similar electrode called the carbon 501. You can buy that in packs of 300, and we sell that for €250. So understand that you can buy smaller packs and get a lower price, so it's 83 cents. So the business model at ZP is, if we can pass on the benefits because to our clients, because some particular product is running in higher volumes, then we'll pass on that benefit. So what I'm essentially doing here is passing on a benefit, that something that we do manufacture in high volume. And what I'm trying to do at ZP is I try to make sure that, when you're manufacturing, you should be manufacturing at least weekly. What happens in the screen printed electrode world is people carry tens and tens of, even hundreds of designs, but what you find out is that they're not really manufacturing them. They manufacture them, they put them on the shelves, they very slowly release them to the market. So you actually end up with very variable products, especially batch to batch variability, because they may only produce something every 2 years. So that's not really manufacturing. That said, you wanted this product. Honestly, this is like a 4mm diameter. This guy is like a 2mm diameter. It really makes very little difference in practicalities. This has got a carbon working electrode, a carbon counter electrode, a silver chloride reference electrode. So is this. This has got a carbon counter, carbon working, and silver chloride reference. It also has I would say is a better design because the counter electrode is larger, which helps both from an electrochemistry but also from a power consumption as well. And it's 83 cents, and you can buy much smaller pack sizes as well. Question number 2. So now, question number 2, they're trying to measure in dairy products. So they were interested in whether we can do a kind of a combination of copper, nickel, and carbon screen printed electrodes. We can. I'm desperately trying to make that you don't, because when you describe that, copper, carbon, nickel, and then as a dielectric as well, that's kind of 4 prints, 4 different materials. That's you know, it's simple enough in terms of manufacturing, but in terms of screen printed electrodes, it's something that's a bit more complex. So you're going to suffer from having a unique product. I think you will actually end up suffering quite a lot, especially in production. And I'll talk about production and reproducibility in a bit, but the quick answer is you will be able to see from this link that we are, you know, making copper and nickel screen printed electrodes. Looking at the kind of thing that I think you want, I think that you have a sort of a carbon working electrode, a silver chloride reference, and then not quite sure what you're doing on your counter electrode. But if you're doing discrete measurements, one-off measurements by voltammetry, in the counter electrode really shouldn't be too much of a problem. And actually, I'm going to recommend that you go with. So this is the list of the most commonly manufactured electrodes that we have, and I think you either go with the carbon 501 or you go with a hyper value carbon electrode here. There will be links underneath the videos. The nice thing about the two ones I've highlighted is we produce them in high volume. High volume equals reproducibility. Reproducibility is part of quality, especially if you're doing voltammetry, because with voltammetry, you will want a reproducible surface so that those peak positions are indicative of the analyte of interest, and then the area under the curve is also indicative of how much of that molecule is in that solution. And if you've got variability in your production on those electrodes, it's going to give you noise in your signal and confuse your algorithms. So I'll make those recommendations. Don't go down this unusual, exotic materials. See, the problem with making bespoke electrodes, when you make something very specific for someone. So I have said, please come to our webinars, both the Sense It All and the Food Sense, because if you watch our webinars, you'll see us using our Sense It All product in that, and you'll see that there's no calibration. And the reason that ZP produces lots of real-world applications, and we sell them into the food testing industry, the reason that we can do no calibration is because we take care of manufacturing reproducibility. When you have calibration in the field, and you will see it in some products, and you also see it in a lot of scientific papers, when people end up normalizing their data, it's because they don't really have a reproducible screen printed electrode. So you'll see no calibration in any of our demos of our products, and that's because we're taking the sheets of electrodes, and it's quite relevant to questioner number 2, because actually we test them by voltammetry. We never ship sheet 1. Sheet 1 is almost like your setup sheets, but we test it by voltammetry. You can see that we're selecting sheets throughout the run and checking them by voltammetry every time. And at the end of that, then we'll know that, you know, a particular sheet within the run had a 6% relative standard deviation. Another sheet had 5%, another one had 6%, another one had 6%, and then we're also tracking the entire production. You know, so is the intensity or the peak height increasing through the run, decreasing? And in this case, you can see it's, you know, I would describe that noise as kind of random. You know, it went low, high, low, high. You know, so there's so we do check the quality through the run, and we do that because we're the biggest users of our own screen printed electrodes, but then we can pass on the benefits to other people using our electrodes as well. And the two electrodes that I have recommended to you, the hypervalue carbon electrode and that carbon 501, if you do the maths, you know, we're shipping the packs of 300 at 250 euros. It's 83 cents each. So it's good to start off with something that's a bit more standard, but we can. I also have linked to the fact that we have, you know, copper and nickel screen printed electrodes, so we can do that. But I would not recommend it as a route to go. What it means is we do make voltammetric assays, and if I check one of our assays at a low concentration, at a medium concentration, or still low, but you know, increasing the concentrations every time. I'm doing this in triplicate, and you can really see the kind of reproducibility and separation of concentration. So if it's signal versus concentration, we've got a nice sensitivity, and there's good, you know, separation between the raw signals here. So the reason ZP ships a very reproducible screen printed electrode is because ZP is actually using them in their own products, and so it's kind of like being a chef, you know, that we definitely eat at our own restaurant. The next thing I want to talk about is relation to question number 2 is really because they want to do discrete measurements. We have a platform called SensiAll. So SensiAll has 2 hardware systems. It has one for optical assays, and it also has one for electrochemical assays. The electrochemical assay is a very mature product. You'll see a QR code up here in a minute. That QR code will appear a few times. This is a way of downloading the SensiAll platform. SensiAll is an OEM solution for people who want to develop point of need assays in the medical industry or in the food production industry. So that QR code will appear a few times. And this hardware, especially this electrochemical OEM platform, is for people who want to develop their own products. We will have a webinar on it. It's on the 13th of December 2023. Just look at the time now, so not so far out from here. So please sign up for it. SensiAll is very elegant. It looks good. It's got very good mechanical features. It's got very good sort of user experience in terms of these LEDs. These LEDs tell people that the machine's on, that the machine's made Bluetooth connection with the SensiAll app. The app is that QR code there. It tells people that the assay is running. It tells people that data is uploaded to the cloud. So it gives them a really good user experience. So SensiAll really for us it's both a product for our end users. So if you're using our screen printer electrodes, especially that 501 carbon I was just discussing, and also that 501, in that hypervalue carbon electrode, they'll just click into this. What we do is we use this platform to help people get to their minimally viable product, or even just the actual product as quickly as possible. I think at ZP we have that kind of lean startup mentality, which is, you've got to fail fast or fail to success or get to success much quicker than would have otherwise taken. So you take these screen printed electrodes, you take the hardware, that app that I was talking about earlier on will make Bluetooth connection with the hardware. The app will, through the QR code, the app then knows what method files to run. It will tell the hardware what to do. And so what will happen is, and then it will also pass the data onto a system called Julie. Julie's a cloud database, a cloud data management system that we've run for 9 years. So there's a lot of maturity in Julie. It's had hundreds of thousands of man hours put into it. So what happens is you take the screen printed electrode, you put that onto the device, you put the sample onto that, the app tells the device what to do, the assay is run, come to one of the assays to see this, come to one of the webinars to see this happen in real time. The meter gives the data back to the app sends the data to Julie, and Julie then sends the data back to sends the number back to the user. What this means is that for every assay run, you get that stored in your cloud or in the cloud, and you can, you get the raw data itself. This is really important for you as the developer or the original manufacturer of this product, because you can do quality control to make sure everything is working okay. So we have, for example, clients in India, and the clients will say, "Oh, I don't think the number's right," but we can literally, with their permission, go out there, look at their raw data, and I can say, that is the signal, and I can explain the signal to them. So you're not left in this kind of situation where somebody says, "Oh, well, I think there was something there, but you didn't see it." It's like, no, you can see the raw data, so you can actually ensure your kind of quality to your end users. So Julie gives the numbers, gives the number, be it parts per million, millimolar, whatever the units. Sometimes we use SHU, Scoville heat unit. So it gives that back to the app, so the user gets it on their phone. But also we have an API system as well. So, obviously everyone wants to use their own cloud. We understand that, but it's nice to have the benefits of a cloud that's had sort of 9 years of development in it. And so the API, the application program interface, is a way of pulling the data from our cloud to your cloud. This is just a few videos talking through the different systems. One of them has got me in it. There I'm just talking through on the actual hardware itself. The hardware is really elegant. This is not powered up, so you don't see the LEDs, but it has an on-off switch on it. Has the LED strip along the front. Has some very nice mechanical features, the way we can kind of click up and click down and just put those sensors in and out on that. It's fairly elegant. You can see at the heart of that there, I'm using one of the hyper value electrodes, and there you see the way it clicks up. If you're in a kind of industry where sometimes somebody, you know, for whatever reason is a bit clumsy and sort of spills it, you can pull that apart, and you know, you can have a sort of, you know, a quick clean. So they can get in there and clean that out. In some industries, you know, if the materials are a bit messy, then, you know, for whatever reason it can be cleaned out. In the other video, the engineer is just showing the total system. You know, in fact, she's showing the Sense It All there. She's probably even downloaded the software, is installing it. Yep, she's installing it there. She connects to the hardware device via Bluetooth. It's just the robustness of the system that's really good, and robustness doesn't come for free. You know, robustness comes from spending, you know, at this point, you know, 9 years, we're over 9 years old, you know, just refining this. This has always been what we've been building towards. And then the last one really is just, and I'll, just a demonstration that if somebody's working with us, we can develop a QR code that they can ship with their products, and the person could just, the first user to get, when they open the box, they scan the QR code, it puts the app into the right state, and essentially off you're essentially ready to go. We do have a lot of electrochemical sensors at ZP, and I think it sort of reflects when we talk about screen printed electrodes, and we talk about assays, and we talk about actual sensors. It's based on a, you know, at least with myself alone, and I'm only one person in this business, you know, 23 years of experience. This is the Sense It All app. You can scan that and install it on an Android. These are the QR codes. So this will just show you that one app, when we say Sense It All, you can go kind of chili, you can go ginger, you can go nitrate, you can go TAS. But I should also say you can go your own way as well. We're not trying to put you, we think the first user experience, especially for the alpha and beta testers, they'll just scan a code that's unique to you. That'll reskin everything, put the app into the right state, and off you go, essentially. There is a live webinar, Sense It All, as I mentioned, on the 13th of December. It's probably worth having a look at that. Also, it's probably worth understanding that ZP, you know, the reason that ZP exists in some ways is because we want to get people to market as quickly as possible. So how do you do that? Well, for example, if they're trying to make a discrete food testing application, then you make really good screen printed electrodes and you try to make them reproducible. The reproducible, and you try to make them at scale as well. So if you make something at scale, you can get it fairly low cost. If you make it at scale, you can get it actually quite reproducible. And so you're solving a problem, because in the past, startups would just start trying to make bespoke electrodes or trying to print in-house, and it wasn't really the value add. The value add is actually the application and getting the application into the customer's hands. It's not having to do all this lifting of technologies in order to just get a unit together. With the other, and then we have hardware. So we have Sense It All, which basically, if it's an electrochemical assay and it's polyvoltammetry, then we can just translate that assay onto essentially a QR code. The QR code will tell the hardware what to do, and the hardware is good to go. I mean, it's really quite simple. So then we have the last problem, which is how to do order fulfillment. So at ZP, we do have a drop shipping service. We use this with our clients. So you have your client. I mean, it's really important that's part of the value of a business, is to do its sales and marketing and to attract its clients. But having attracted that client, people then have to build a whole operations in order to just get that client a unit. So what we do then is you have essentially a sale. So you have your client's order. That then gives instructions to us, and we'll take the sensor. Now, let's say you were actually at ZP, we do the functionalization of screen printed electrodes as well. So we make a screen printed electrode that allows people to do R&D upon it, but we also use those in our own programs when we're developing sensors for other people, and we also use those as the basis for doing contract manufacturing for people as well. So there's a sensor, there's hardware. I've described the Sense It All. There's also webinars on the 13th of December. Those two things together, plus the app, constitute essentially a product, or the start of a product. So those two things get boxed, for example, close the box, and we direct ship it to the particular client. That's really important, because otherwise you're building up a whole operations team and you're probably trying to support that whole operations team on a very small number of orders, especially in your first and second year. So the fact that you can actually reduce it down, you can reduce operations or at least order fulfillment down to a simple instruction. Here's the client, here's the address, drop ship it here, thank you very much. The fact that you can just reduce it down to something like that really saves time and money, and probably allows you to kind of do things that are actually more valuable, which is probably the software and the algorithms I suggest, and adding value to the data, and also the value of actually understanding the clients and penetrating the market. You know, those are value adds, and order fulfillment is not a value add. It's just a means to an end. So question number one, let me just revise myself. So the chloride resilient electrodes from ZP are designed for applications where there's no chloride, or you want to have a really fixed potential on that reference electrode. Question number two, we don't do the desalination cell anymore. Question number 1C, if you order the copper screen printed electrodes, and our standard shipping is 3 to 4 weeks. We don't do the AACC 101N in small pack sizes, but the carbon 501 is an equivalent and, you know, I would say better system and cheaper, and you can buy it in smaller pack sizes. Question number two, I would suggest don't go for specialized screen printed electrodes. I would say get some consulting of ZP, because we're really good at stopping people actually having to require specialized materials. Once you get specialized materials, you know, you can't get the quality, and you will find people on the market who will do it for you, but you'll always suffer from reproducibility until you get to really high volumes. And 10,000, 100,000 electrodes is not really high volume. The fact that you need a one-time use electrode means that, yeah, screen printed electrodes are good. It's quite nice that even our R&D price is 83 cents, which gives you a good cost structure for being able to make a one-time system. You know, we are very experienced in nickel, copper and carbon, though I would suggest the carbon 501, and I would suggest the high provided carbon electrodes. 10,000, you know, of those is really no issue. And I have suggested to you really the route that you would want to go. If you want to, like I say, I'm quite experienced, like quite pragmatic. If you want to have a consultation meeting with me, let me know. So that's it. So thank you very much. So sorry that was quite a long one this week, but these short questions are actually quite nuanced, and you can see we put quite a bit of effort in thinking through on these. So if you have any questions as ZP, please don't hesitate to reach out to us. Okay, thanks very much.